Hi, today's lesson will be on adding and subtracting radical expressions. In order to be successful in this section, it is imperative that you have learned how to successfully simplify radicals by using the factor trees and simplifying it that way, not just putting it in your calculator. So the objective of this lesson is to learn to simplify these radical expressions when they involve addition and subtraction. So the first example we're going to do is one where we are simplifying like terms. So what I mean by like terms is similar to when we have expressions with like variables. If I was to add 3x plus 6x minus 2x, then I would be combining the coefficients because these are like terms. So in other words, I would take 3, add 6, and subtract 2, but my x would remain the same. So 3 plus 6 is 9. 9 minus 2 would be 7x. Similarly, when we recognize that we have like terms, notice all three of these terms have the square root of 11. That simply means we want to take the 3, the negative 6, the positive 6 and the negative 2 and combine them, leaving the square root of 11. The 3 plus 6 again is 9, minus 2 is 7, square roots of 11, and we want to stop there. However, we can verify our answer in our calculator. So in your calculator, I would want you to turn it on, then type in your original problem, so 3 square root of 11, close your parentheses, plus 6 square root of 11, minus 2 square root of 11, and we would get a decimal approximation of 23.2. If we type in our answer that we got, 7 square root of 11, and hit enter, we should end up with the same decimal value. This informs us that our answer is indeed correct. Next, let's try another one. Sometimes you will see problems where you do not have all the same terms that are like. Notice when we look at our radicand, which remember is the value under our radical, we have 7, 2, 2, and 7. The like terms will be the terms that have the same radicand. So 9 square roots of 7 plus 5 square roots of 7 are like terms. So I'm actually going to group those together. 9 square roots of 7 plus 5 square roots of 7. And I want to combine that with these two terms. These have like terms because their radicand is 2. So I'm going to group them together. Negative 4 square root of 2 plus 3 square root of 2. So when I combine these, again, remember you only add the number out front, similar to having coefficients of x. So 9 plus 5 is 14 square roots of 7. Plus we have a negative 4 plus 3. A negative 4 plus 3 is a negative 1. But of course we do not want to leave our answer with a 1 in front, similar to how we would never leave an answer of 1x. Okay? We would just simply state that as x. So similar to that, we want to make sure that we do not include the 1, but also recognize that if we are adding a negative, it's the same thing as subtraction. So notice on the PowerPoint slide, there's kind of two different approaches to get the same thing. So you can kind of rewrite it. You are allowed to rearrange the terms so that they are, so you do have like terms next to each other, so like they did in the PowerPoint. Again, we can check this in our calculator to see that we get the same decimal approximation. So these two examples that we've done previous were like radicands as soon as we look at them, and we also cannot simplify them any further. Notice 7 is a prime number. Its only factors are 7 and 1, and 2 is a prime number. Only factors are 2 and 1. So we cannot continue to break this down. However, in order to simplify a lot of radical problems, we are going to have to simplify them first. Then we can use the distributive property to further simplify the expression. So the next example I want to look at, and I'm sorry it's called example 4, but it is our third example. We'll call example 4. Simplifying with unlike terms, meaning we have different radicands. Looking at 7 square roots of 98 plus 5 square roots of 32 minus 2 square roots of 75. We're going to have to employ some strategies that we learned yesterday. So neither recognize these are like terms. So we need to start by breaking this down. Now, like I taught you yesterday, if you have an even number, you can always divide by 2 to start simplifying. When we do, we get 2 times 49, and 49 breaks down to 7 and 7. Notice, like yesterday, I'm underlining in my factor tree when I get to a prime factor. 32 is also divisible by 2. It is even. But you may also remember that 32 divided by 4 is 8. So you can also start with 4 and 8. 4 breaks down to 2 and 2. 8 breaks down to 2 times 4, where 2 is prime. 8 breaks down to 2 and 2. And now we have all of these factors. Lastly, we'll break down the square root of 75. It is divisible by 5. So 75 divided by 5 is 15. Or, of course, you could do 3 times 25. That would be fine as well. 3 times 5. So now I'm done completely factoring these. So I'm going to take all of my values here that are underlined and put them under each radicand. So 2 times 7 plus 5 square roots of, there are 1, 2, 3, 4, 5 2's, minus 2. And notice I'm just carrying down the 7, the plus 5, and the minus 2 in front. I cannot lose track of that. Square root of 3 times 5 times 5. Remember from yesterday, when we simplify a square root, because our index is 2, we are looking for pairs of the same factor. So I have one group of 7. So this is for this 7. I pull out one group of 7, square root of 2, plus, bring down the 5. I'm going to pull out a 2, then another 2, so that's 2 groups. And lastly, I have a pair of 5s that will come out. So that will leave me with a 1 5 out here, and I leave the square root of 3. Next, I want to simplify. So 7 times 7 is 49, square root of 2, plus, remember 2 squared is equal to 4. So 5 times 4 is 20. Oops. Minus 2 times 5 is 10. Now when we look at this, we need to further recognize that if we have any like terms, they also need to be combined. Notice your radicands of 2 are like terms, so we're going to combine the 49 and the 20. 49 plus 20 is equal to 69, the square root of 2. Because this does not get added, we simply write it as part of our final expression. And we can also verify by putting our original problem in our calculator and our answer in our calculator, and we should get the same decimal approximation. I'll give you another one here. With this example 5 here, it says simplify, then use a calculator to verify your answer. So 3 square roots of 7 minus 2 square roots of 28. Recognize to start with that we do not have like radicands, but we can simplify this one here. 7 is prime, it cannot be broken down any further. So when I break down 28, I know that 28 is the product of 2 and 14. You can of course always start with different factors. So you could do 7 and 4, that would be fine as well. But 14 breaks down to 2 and 7. So now I have all of these prime factors. I'm going to rewrite this by bringing this down, and then in place of the square root of 28, rewrite it as the product of 2 and 2 and 7. Now hopefully you've caught on that anytime we see a pair, that's going to come out. If you forget, remember that this is really 4, and the square root of 4 is 2, so it's kind of like we're just bringing out that 2. Bringing out the square root of 4, which is 2. But of course, with this 2 outside, we must multiply these together. As you see now, we have like terms because our radicands are 7. So that means we're going to combine 3 minus 4, and 3 minus 4 is negative 1. But remember, we don't want to leave that 1, similar to how I showed you earlier, so let's just rewrite it as the square root, or negative square root of 7. So to verify that in our calculator, we're going to again type this in. 3 square roots of 7 minus 2 square roots of 28. Hit enter, then type in our answer, and notice we get the same value. So please don't forget to do that. It's a great way to check and make sure your answers are correct. Thank you very much.